Breathe better and sleep deeper with the Levoit Classic 160 Top Fill Humidifier. Don't wait. Check out the link in the video description to get your Levoit Top Fill Humidifier on Amazon today and enjoy a healthier, more comfortable home. Welcome to VolcanoWatch News. I'm your host, and today we're going to talk about one of the most iconic volcanoes on the planet. Now, you might be thinking, Yellowstone? Isn't that just a national park in America? Well, yes and no. Yellowstone is indeed a massive park with geysers, hot springs, and an abundance of wildlife. But it's also home to one of the most powerful volcanoes on Earth, a supervolcano. When we think of supervolcanoes, images of giant eruptions come to mind. And let me tell you, Yellowstone has had its fair share of those. The last major eruption was about 640,000 years ago, and before that, it was 1.3 million years ago. These eruptions were so massive that they changed the climate on Earth, making it colder. But here's the thing, Yellowstone is unlikely to erupt anytime soon. In fact, a new study using magnetotellurics has found that there's not enough molten material pooled in one place to trigger a massive eruption anytime soon. So, what makes Yellowstone so special? Well, it's actually a hotspot where large areas of molten material stay in one place as the Earth's tectonic plates move around. This type of magma is called basaltic, and it tends to produce pretty mild eruptions. Think Hawaii. That's a basaltic hotspot too. However, hotspots can also melt the material around them, changing the composition of the lava and producing a type of molten material called rhyolite. And that's where things get interesting. Rhyolite is more viscous than basaltic magma, which means it doesn't flow as easily. When it erupts, it can cause explosive eruptions. The problem is that telling the two lavas apart is difficult, particularly when they're several kilometers underground. So, scientists use a variety of methods to survey the Yellowstone subsurface. The seismic method is one of them, by measuring how seismic waves travel through the Earth's crust. Researchers can infer the composition and structure of the subsurface. But even with these methods, there are limitations. That's why researchers have started combining seismic data with other techniques like magnetotelluric imaging. Magnetotellurics is a passive geophysical method that uses natural time variations of the Earth's magnetic and electric fields to measure the electrical properties of the subsurface. This approach has provided invaluable insights into Yellowstone's subsurface, revealing 7 distinct low-resistivity anomalies beneath the park. These anomalies correspond to regions of partial melt or hydrothermal activity. Some areas are made up of basaltic melts, while others contain rhyolitic material. And get this, the melt fractions in these rhyolitic reservoirs were well below the threshold considered eruptive. Now you might be thinking, so what does this mean for Yellowstone's future? Well, it means that a major eruption is unlikely anytime soon, but there are still risks involved. The largest rhyolitic storage zone lies under the northeast part of Yellowstone caldera, with a volume comparable to the smallest past caldera-forming eruptions. But here's the thing, this magma system appears to be shifting towards the northeast region. This could lead to localized eruptions or increased hydrothermal activity in that area. So, while a major eruption is not imminent, it's still worth keeping an eye on Yellowstone. In fact, researchers are already monitoring the northeast caldera's active magma system. The study published in Nature has significant implications for hazard assessment. And that's exactly what VolcanoWatch News is all about. We'll keep you updated on any new developments in Yellowstone's volcanic activity. That's it for today's episode of VolcanoWatch News. Thanks for watching, and we'll catch you next time.